Hi, my name is Oktay. Welcome to today's video about outer Milky Way Galaxy. This is a nice artist's impression of the Milky Way Galaxy or home galaxy. It's a spiral bar galaxy. Diameter is 100,000 light years. The length of the bar is about 25,000 light years. The Milky Way contains 100 to 400 billion stars. Total mass is somewhere between 0.89 to 1.5 billion solar masses. And you can see the big spiral arms, which are density waves. Our solar system is halfway out in the middle of the disk, about here, at a distance of 26,000 light years from the center of the Milky Way. In a minor spiral arm, that's the Orion arm. And the age of the Milky Way Galaxy is 12.6 billion years. For comparison, the age of the universe is 13.8 billion. This is a nice collection of pictures taken from the Hubble Space Telescope surveys of all the types of galaxies. And the y-axis, you have the types of galaxies, and the x-axis, the age of the galaxies. And you can see the oldest galaxies at the right are also the smallest galaxies. And this is a nice artist's impression of how the bigger galaxies were produced by an ancient galactic mega merger. Several small galaxies merged, and this led to the formation of the big galaxies like the Milky Way Galaxy. This is an artist's impression of dark matter distribution, which is here in blue, which makes 90% of the matter of the Milky Way Galaxy. It is essential for the structure of the Milky Way. Without the dark matter, there's no way the Milky Way Galaxy could keep its structure. This is a nice artist's impression of rotating disk of our present day and the ancient galaxy. The present day galaxy is on the left, and the ancient galaxy is on the right. And in this picture, the dark matter is in red, and this is how both galaxies rotate. So the present day galaxies rotate much faster because the dark matter has migrated towards the middle. Ancient galaxies rotate much slower because the dark matter is distributed more evenly. This is a nice picture of all the features of the outer Milky Way Galaxy. You get have the inner halo and the outer halo. Then you have globular clusters, open clusters, gamma ray bubbles, streams like the Magellanic Stream, and satellite galaxies, for example, the Small Magellanic Cloud and the Large Magellanic Cloud. These are the features of the outer Milky Way Galaxy. This is the structure of the halo of the Milky Way. You can see the thin disk. Thin disk has a thickness of about 1,000 light years. Here's the inner halo and the outer halo. The halo of the Milky Way has a diameter of 2 million light years. 90% of the stars lie within 100,000 light years of the galactic center. This is a picture of a few of the globular clusters. The Milky Way has over 150 globular clusters. These are spheroidal structures of stars bound by gravity. And the stars in the globular clusters are older stars with a low metallicity. Metallicity means percentage of elements other than hydrogen and helium. These types of stars are called population 2 stars. The Sun is a population 1 star because it is of a newer generation and has a higher metallicity. Most of the clusters are around the galactic core. This is one such example. It's a Hubble image of the globular cluster Messier 22. Messier 22 was discovered in 1665 by Johann Abraham Ehle. It is at a distance of 10,600 light years and has a size of 100 light years. This globular cluster contains 80 to 100,000 low metallicity stars. This is an example of an open cluster. That's Pleiades at 444 light years. There are over 1,100 open clusters in the Milky Way. The difference is the open clusters are loosely bound. And in this case, this is a group of B stars. The B stars are massive stars, far bigger than the Sun. This is a picture of the Fermi Bubbles. They go 25,000 light years above and below the galactic center. The total size is 50,000 light years. And you can see here X-ray emissions and gamma ray emissions. And these Fermi bubbles are caused by the supermassive black hole Sagittarius A star in the center of the Milky Way. This supermassive black hole has a mass of 4 million solar masses. This is a nice picture of the stellar streams in the Milky Way Galaxy. This is the disk of the Milky Way Galaxy. It has a size of 100,000 light years. For example, this big stream has at least a size of 200,000 light years. And another example is the Magellanic Stream that comes from the interaction of the small Magellanic Cloud with the large Magellanic Cloud. These streams are produced by galactic mergers and interactions of galaxies. This is a nice animation of what happens to a dwarf galaxy if it comes into the gravitation field of a bigger galaxy. The bigger galaxy is not shown in this animation. And you can see it is stretched, and it circles several times around the bigger galaxy. And eventually it will become a part of the bigger galaxy, and it will merge with the bigger galaxy. Now this is one such example. It's an artist's impression of the Virgo stellar stream, which is also called Virgo overdensity. This are the remains of the dwarf galaxy, which is still in a merging process. This stream is at a distance of 30,000 light years from the Sun, and its size is also 30,000 light years. This is one very mysterious object. It's Smith's cloud. It was covered by Gale Smith in 1963. This is a high velocity gas. Its size is 11,000 light years by 2,500 light years, so it's quite big. Its mass is 1 million solar masses. And measurements with the Hubble Space Telescope showed that this high velocity gas its origin is the Milky Way disk. It has the same composition as a Milky Way disk, outer Milky Way disk. So this is where it is today. This is what happened 70 million years ago, but it is not clear what happened, what caused this cloud. And 30 million years from now, the Smith cloud will come back and will eventually merge with the Milky Way disk. This is a picture of a few of the 59 satellite galaxies of the Milky Way. These satellite galaxies are within 1.4 million light years of the Milky Way. Only the small Magellanic Cloud and the large Magellanic Cloud are visible to the naked eye. This is the small Magellanic Cloud. It's an irregular dwarf galaxy at a distance of 210,000 light years. Its size is 18,900 light years. It contains 3 billion stars. And here on the right, it's the globular cluster 47 Tucanae. This is the large Magellanic Cloud. It's a spiral galaxy, a distance of 157,000 light years. Its size is 32,200 light years, so it's quite big. The Large Magellan Cloud contains 30 billion stars, and there's a bridge of stars to the Small Magellan Cloud. In this bridge, there's a star formation. The Large Magellan Cloud will merge with the Milky Way in about 2.4 billion years. There's another dwarf galaxy, that's the Sagittarius dwarf spheroidal galaxy. It is here. It is at a distance of 50,000 light years from the Milky Way center, and its distance to the solar system and Earth is 70,000 light years. This dwarf galaxy is on a polar orbit around the Milky Way Galaxy. It's like this. This is Messier 54. It's an image from the Hubble Space Telescope. Scientists thought that this globular cluster was a part of the Milky Way Galaxy, but that's not true. It is part of the Sagittarius dwarf galaxy. Its size is 300 light years. And it could be that this globular cluster contains an intermediate black hole with a mass of about 9,400 solar masses in the center. There are three types of black holes: the stellar black holes that are final stages of the big massive stars, and the supermassive black holes with a mass of millions to billions of solar masses. They sit in the centers, the galaxies. And the third group is the least known, that's intermediate mass black holes with a mass of thousands to 10,000 solar masses. They're difficult to find, and it is not clear how they were formed. They're a mystery. This is a comparison of the biggest galaxies in the local group. Number 1 is the Andromeda Galaxy. Number 2 is the Milky Way Galaxy. And number 3 is the Triangulum Galaxy. A Large Magellan Cloud is the 4th biggest galaxy. The biggest is NG 3109. And the 6th biggest is the Small Magellan Cloud. This is a very beautiful picture of the Andromeda Galaxy M31 taken from Earth. And you can see two of its satellite galaxies. At the top, that's M32. And at the bottom, that's M110. The Andromeda Galaxy has a size of 200,000 light years, and it contains 1 trillion stars. This is what will happen in about 4 billion years from now. And that's a collision of the Milky Way with the Andromeda Galaxy. They will collide and eventually become one galaxy that's called Milky Way Galaxy. This merger will initiate a starburst, rapid star formation. And the third galaxy, Triangulum, a few billion years later will also join this process, and it will also merge with these two galaxies. This is a picture of the Laniakea Supercluster. It has a size of 520 million light years. This is here, the local group. This is where we are. The Laniakea Supercluster contains 100,000 galaxies. They are not bound gravitationally. In the big scale, you have the dominance of dark energy, which works against gravity. And the mass of the Laniakea Supercluster is 100,000 times that of the Milky Way Galaxy. This is another very nice artist's impression of the Milky Way Galaxy, our home galaxy. And what I really like about astronomy is that it goes to the limits of the human imagination. That was today's video about outer Milky Way Galaxy. Thank you for watching. Have a nice day. Bye-bye.